This isn't just a galaxy, it's a violent trillion-star monster hiding in plain sight, and it's hurtling right towards us. For a decade, scientists pointed the Hubble Space Telescope at our galactic neighbor Andromeda, piecing together the largest, most detailed portrait of another galaxy ever created. What they found wasn't a serene spiral, but a battlefield of cosmic collisions with a turbulent past and a shocking future that involves us directly. Let's explore this incredible story together. 1,000 years of discovery. How do you see a galaxy 2.5 million light-years away without a telescope? For centuries, it was just a smudge. The first person to write it down was Persian astronomer Abd al-Rahman al-Sufi, who in 964 AD described it as a nebulous smear in his Book of Fixed Stars, a foundational text in astronomy. He was observing from Isfahan, a location with dark skies we can only dream of today. For over 600 years, that's all it was. Then, on December 15, 1612, German astronomer Simon Marius aimed his new telescope at the smudge and became the first human to resolve it with more detail, describing it as looking like the light of a candle shining through horn. This was a crucial step beyond just seeing a cloud. Over a century later, in 1764, the famous comet hunter Charles Messier gave it the designation it still holds today, Messier 31, or M31, cataloging it to prevent other comet hunters from mistaking it for a new discovery. His catalog of things to not mistake for comets ironically became a list of the most spectacular deep sky objects. These early astronomers were looking at the same object we see today, but they had no idea of the true scale of what they were witnessing. The Great Debate. So, what exactly was this majestic spiral? For decades, that question sparked one of the most intense arguments in the history of science, known as the Great Debate. In 1920, two prominent astronomers, Harlow Shapley and Heber Curtis, went head-to-head at the Smithsonian Museum of Natural History. Shapley, a brilliant and forceful personality, argued that our Milky Way galaxy constituted the entire universe. His evidence was his recent work on globular clusters, which showed the Milky Way was vastly larger than previously thought. He believed these spiral nebulae were simply gas clouds swirling within its boundaries. On the other side, Heber Curtis argued for a much grander cosmos. He championed the radical idea that these were distant island universes. Curtis pointed to the greater number of novae, exploding stars, in Andromeda compared to the rest of the Milky Way, calculating they must be incredibly distant to appear so faint. He also noted the presence of dark dust lanes in Andromeda that looked strikingly similar to those in our own galaxy. This wasn't a minor academic disagreement, it was a fundamental clash over the scale of existence itself, a debate that defined an entire era of astronomy while awaiting a definitive answer. Hubble's revolutionary finding. One man, one discovery, and suddenly the universe became terrifyingly vast. That man was Edwin Hubble. In the early 1920s, the astronomical community was fiercely divided following the Great Debate. Then, in 1925, using the most powerful telescope in the world, the 100-inch Hooker telescope at Mount Wilson, Hubble settled the argument for good. He discovered special stars in Andromeda called Cepheid variables. Thanks to the groundbreaking work of astronomer Henrietta Swan Leavitt at the Harvard College Observatory, it was known that the pulsation period of these stars is directly related to their true brightness, making them perfect standard candles. Leavitt's discovery was the key that unlocked galactic distances, though she received little credit in her lifetime. By observing how long it took these stars to pulse, Hubble could determine their intrinsic luminosity. By comparing their true brightness to how dim they appeared from Earth, he calculated their distance. His calculations placed Andromeda nearly 1 million light-years away, far beyond the accepted boundaries of the Milky Way. In a single stroke, Edwin Hubble proved Andromeda was a galaxy in its own right, vindicating Heber Curtis and forever changing humanity's place in the cosmos. A new portrait emerges. Even after we knew Andromeda was a galaxy, getting a truly clear picture remained a monumental challenge. From our vantage point deep inside the Milky Way, it's like trying to map a forest while standing among the trees. Dust and stars get in the way. This is what led to one of the most ambitious projects in Hubble's history, the Panchromatic Hubble Andromeda Treasury, or PHAT program. For years, a dedicated team led by principal investigator Julianne Dalkinton used the space telescope to systematically photograph a massive swath of our neighbor. The term panchromatic is key. It means they observed it in multiple wavelengths of light, from near ultraviolet to near infrared. This allowed them to see stars of different ages and temperatures: hot, young, blue stars, and cooler, older, red stars. The project spanned 411 individual telescope pointings, creating thousands of images that were then painstakingly stitched together. Finally, in January 2015, NASA released the result, the largest, sharpest image of Andromeda ever assembled. It's a breathtaking 1.5 billion pixel mosaic revealing over 100 million individual stars. A treasure trove of data that provides the first truly comprehensive view of a large spiral galaxy's stellar populations. The Ring Mystery. Look closely at Andromeda, and you'll see something strange, ghostly rings of dust and stars that shouldn't be there. For years, these features puzzled scientists. In the incredible Hubble mosaic, you can clearly see a massive, elliptical ring of star formation in the outer regions, populated by hot, young, blue stars. This is bizarre because in a normal spiral galaxy, star formation follows the density waves of the spiral arms. A distinct offset ring points to a sudden galaxy-wide disturbance. In 2006, using the powerful infrared vision of the Spitzer Space Telescope, a team of researchers led by astronomer David Bloch discovered a second, hidden inner dust ring. This one had been hiding in plain sight, as its dusty nature made it invisible to optical telescopes, but glowed brightly in the infrared. Two distinct rings meant this couldn't be a coincidence. David Bloch himself offered a powerful analogy, describing the dust rings as being like ripples in a pond. And what causes ripples? An impact. This discovery was the first major clue that Andromeda's past was far more violent than its serene appearance suggests. Scars of ancient collisions. If Andromeda was punched, who threw the punch? The leading suspect was one of its small satellite galaxies, Messier 32. To test this theory, David Bloch and his colleagues ran sophisticated computer simulations in 2006. They modeled a scenario where a smaller galaxy plunged head-on through Andromeda's disk about 210 million years ago. As the intruder passed through, its gravity triggered a massive shockwave of gas and dust that expanded outwards, creating the rings of starburst activity we see today. The simulation almost perfectly reproduced the two major rings seen in the observations. But this was only one piece of the puzzle. Deeper investigations of Andromeda's faint outer halo by astronomers like Puragra Guhathakurta using the powerful Keck telescope in Hawaii revealed more subtle, ghostly streams of stars. A galaxy's halo is a vast spherical region of older stars and dark matter surrounding the main disk, and it's the perfect place to find the debris of past mergers. These stellar streams were undeniable evidence that Andromeda was a serial cannibal, building its immense size by consuming smaller galaxies over cosmic time. The giant southern stream. The rings were just the beginning of the story. Deeper analysis revealed a wound far larger, a river of stars torn from a cannibalized galaxy. While too dim to be seen clearly in the main Hubble image, other surveys have revealed a mammoth feature called the Giant Southern Stream. This is a vast trail of stellar debris that stretches for hundreds of thousands of light-years from Andromeda's southern disk out into its halo. First identified by a team including astronomer Rodrigo Ibada, this stream is a dissipationless structure. Its stars are cold, contain no gas, and move together like a ghostly river, their paths dictated solely by gravity. Finding such streams involves meticulously analyzing the motion and chemical composition of millions of stars to find the ones that move together and share a common origin. It's kind of like finding a single drop of dye that has been stretched across an entire ocean. The sheer scale of this structure, far larger than Andromeda's visible disk, is undeniable evidence of a major merger event, something far more destructive than the punch-through collision that created the rings. M32. The smoking gun. The evidence now pointed to at least two major collisions, a recent one that created the rings and a much older one that formed the giant southern stream. Could they be related? A groundbreaking 2018 study put the spotlight back on the prime suspect, M32. Astronomers Richard D'Souza and Alistair Crane proposed a unified theory. They suggested that the M32 we see today is merely the dense, stripped-down core of a much larger galaxy that collided with Andromeda 2 billion years ago. Their computer simulations showed that this lost galaxy, nicknamed M32P, would have been the third largest member of our local group. The evidence for M32 being a stripped core is compelling. It's incredibly dense, and its central black hole is far too massive for a galaxy of its current size. But it's just right for the massive galaxy it once was. This single violent event neatly explains the rings, the stream, and even why a fifth of Andromeda's stars have a unique chemical signature. It's a compelling theory that paints a picture of Andromeda as a true cosmic predator that wears the remains of its victims. Satellites and secrets. Andromeda isn't alone. It's the gravitational master of a cosmic court, surrounded by dozens of smaller dwarf galaxies, and each one holds a piece of the puzzle. While the M32P merger was likely the most significant event, it almost certainly wasn't the only one. Thanks to the incredibly high resolution of the combined Hubble data from the PHAT and PHAT surveys, astronomers can now hunt for more subtle clues. Researchers like Anil Seth specialize in this kind of galactic archaeology, using faint stellar streams to reconstruct a galaxy's merger history. The PHAT survey, which extended the original program to Andromeda's southern region, was crucial because that part of the galaxy appears far more disturbed. This data also helps tackle puzzles like the satellite plane problem, a mystery where many of Andromeda's dwarfs orbit in a thin co-rotating plane, which challenges standard galaxy formation models. The full story of Andromeda's violent past is likely a complex tapestry woven from one major collision and dozens of smaller skirmishes, a story we are only just beginning to read. Our galactic future. Here's where the story gets deeply personal. Andromeda isn't just a fascinating case study, it's our destiny. For decades we've known it's hurtling towards our Milky Way at a blistering 110 kilometers per second. In 2012, a definitive analysis led by Roland van der Merel of the Space Telescope Science Institute used Hubble to track the subtle sideways motion of Andromeda's stars over several years. This was the final missing piece of the puzzle, confirming our fate. A head-on collision is set to occur in about 4.5 billion years. When it happens, the night sky will be spectacularly transformed as Andromeda fills our view. The two galaxies will then merge over hundreds of millions of years into a new, giant, elliptical galaxy. However, the ultra-precise PHAT survey data has added a new twist. In a recent paper, astronomer Til Sawala used these new measurements to refine the models of the local group's mass. His team's work suggests the collision might not be a dead certainty, with some scenarios allowing for a glancing blow or a near miss. The future is still being debated, but one thing is certain: our galactic neighborhood is not static. This breathtaking image from Hubble has transformed our view of Andromeda from a serene spiral into a dynamic and violent galaxy with a dramatic past. It's a cosmic crime scene, a history book, and a crystal ball all rolled into one. The 10-year effort of the PHAT and PHAT programs has given us an unprecedented census of our neighbor, but the story is far from over. As scientists continue to mine this incredible data set and new telescopes turn their gaze toward our neighbor, we will undoubtedly uncover even more secrets. We are, after all, neighbors, and in a few billion years, we might be getting a whole lot closer. If you found this cosmic journey as fascinating as I did, don't forget to like, subscribe, and hit the bell icon. Thanks for watching Simply Science.